this one I'll just tell you what it should be. Does the surface of the object seem to affect friction? It's hard to get consistent numbers, so it's hard to tell for sure. Some of you had the numbers close together, some of you had the numbers far apart. But what you should find is these kinetic numbers should match up, and these static numbers should match up. So does the surface area of an object seem to affect friction? The answer should be no. If you had yes, know that that's common, but change it to no. Okay. Okay, so why is this? So the reason why it is a couple-fold. So the first thing you can think about is why is this? Is because when you overcome inertia and you get it to start moving, you get all the particles to start moving at once. Not just one of them, not just part of them. You get all of them to move at the same time. Which means it doesn't matter how many they are, how many particles are touching the surface. It doesn't matter how many touch the surface because they all are going to move at the same time regardless. Okay, so they all are going to move at the same time regardless of the surface area. The other couple explanations, it doesn't change, so surface area doesn't change the roughness. So we talked about the cause of friction. Friction is caused by how rough the surface is. If you put it on its side or flat, that doesn't change how rough the surface is. Okay? So there's no difference in the cause of friction. Okay? So because there's no difference in the cause of friction, that's not going to be a change. And the other explanation besides that it doesn't change the roughness is that it doesn't change the object. So not only does it not change the object, it doesn't change the roughness either. So whether you put it on its side, it's still a block of wood. Whether you put it flat, it's still a block of wood. Whether you put it on its side, it's still the roughness between the table and the block. Whether you put it flat, it's still the roughness between the table and the block. So the surface area does not have an effect because it doesn't change fundamentally what's going on. Okay? Fundamentally what's happening, it doesn't change anything about that. Okay? All right. Get the data finished. So most of you are on to part 3. Get the data finished. Get your trials completed. Okay? Get your data done. We'll talk about those last ones next time, but you need the numbers. So get the numbers finished. So what you do is you put the weight on there, hold it. Now then you would put the next one. So here's what I would do. So 300 would be these three. Yeah, just do kinetic. So put these 3 on here, then do 5 on here, then 6. So just numbers, so you at least have some numbers to go on. So you guys get those. All right, go ahead and make sure you get these, at least this first trial done.
How do you do this?
So all you're doing is you're pulling the block with different amounts of weight on it. So you start with like 300, pull it, see what the kinetic is. Change that to 500, pull it, see what the kinetic is. Change that to 600, pull it, see what that is. So that's what it is right there. So get trial 1 done, so you can get at least have some numbers. You guys get on yours. You guys get on yours. Okay. You guys. So let's at least get trial. Don't worry about this for right now. We can do that later. Let's get trial 1 done so you have numbers. So what you're going to do is start out with like 500 here. Pull that kinetic and see what that number is. Write that down. And this. So that would be 200. Pull that. Let's see what that one would be. Do this one by itself. 200 just by itself. So you're writing down like what is getting at the different. So when you change the mass, when you change the weight, how does that affect? Once you've got at least some of the data for part 3, so at least get trial 1 done, put the stuff back where you got it from. Put the stuff back in the cabinet.
It cannot be 0.5.